Hello and welcome to week 4 of the weekly Revit Architecture 2012 tutorial series for interior architects. This week we're going to focus on families, introduction to families basically. We're not necessarily going to get into types this week, but we're going to discuss how to model a basic family, possibly two families. But before we actually start modeling any families, I wanted to take a look at an actual family that's already created. We know by now that Revit, by default, has several families that include doors, windows, things like tags are considered families, grid lines, annotations. All of those things are actually considered families, but some are considered system families and some are considered families that can be edited. To see the families, if we go ahead and go to a new project now, okay, and for now we're just going to go to component, and I'm going to go to load family. Okay, so we've been in this folder before. This folder contains all of the predefined families created by Revit. Like I said before, these aren't system families. These are the families that can be adjusted. For the most part, the system families are uneditable. You can't edit, for example, you can't edit the wall family, anything that's considered to be a system family. So you might need to reference your book to see the exact list. There's a short list of system families that can't be edited. Any of the families in here, though, we should be able to edit without any problem. So let's just take a look at a common, maybe, actually I'm going to go to furniture. We'll look at a simple chair. Let's see. This will work. Now notice I can place this component without any walls. It's not necessarily something that I need walls to place components. These are objects just like walls. So I'm just going to click without any walls just to place this component in here so we can examine it further. Okay, so if I click on this component, I'm going to bring up the properties here. You'll notice anytime that we have a component in the properties box, the name of the component here, the component family, is here. If I click on the drop down, you'll notice that for the chair, for the Corbo chair, there is no types, whereas for the desk we see different types. Okay, so basically this is the desk family with the siblings, so you can imagine this is one of the parents, and these are the three little kids. And the amazing thing about this is the desk was created as a family. These types are adjustments to this family, and that's the introduction of parametric data. So basically, these values are going to produce the same desk. They're just going to be different dimensions. So when you create the family, you create types that will have certain dimensions that adjust according to these dimensions. So we'll look at more, like I said, we'll look at creating types maybe next week. This week we're just concerned about creating the main family. And like I said, this chair actually only has one type, and it's this chair, right? Because there's not different size versions of this chair. There might be a different size version, like maybe a couch available or a love seat available of the same style. And you could do that here underneath. You could do the style of the chair and then have different types being the different lengths of the chair itself, or the different widths. So the types are just subfamilies of the main family, basically. So this week we're going to look at creating the actual family. So if I select the chair and I go up here to edit family, that's going to open the family editor. And again, remember from class what we went over, this bar changes when you're in the family editor. The toolbars at the top are not the same as the toolbars in plan. Just the same as the views over here are not the same. Okay, so they're similar, but they're not the same. So the project browser changes, the toolbars change when you're in the family view. For the most part, you're always going to want to be in the family editor when you create families. We'll find out later that you can create families while you're in the model, but you really want to do that for things like custom casework or things that are really project based. You wouldn't want to, for example, you wouldn't want to create this chair inside the project because you wouldn't be able to use it in other projects. We want these families to be available in all of our projects so we can use them over and over again. However, there will be times where you'll have casework in a closet or in a kitchen or some kind of special cabinetry that is only consistent with that project. In that case, you'll want to do an in-place family. But whenever you're creating free furniture, doors or windows or anything like that, it's usually best to create those in the family editor. And we can do that from the beginning by going to File, New, Family. Instead of Project, we can go here to create a family, and essentially this family is going to represent, if you're familiar with an AutoCAD file, these families are just like blocks, okay? But they have, there's more capabilities for changing them or customizing them as far as the parametric data goes. And we'll look at creating a new one here. I still want to look at this a little more. So if we go through our views here, we'll notice we have our reference floor plan. Okay, this is looking down. We'll see what some of these dimensions actually mean a little bit later, probably more next week than this week, but this is an example of the parametric data here. These parameters are used to adjust the width and height by creating different types. So everything is locked in and constrained together. So we'll look at that further. Front view, you see we have a reference level here. Again, more dimensions. Now these green dotted lines, if you remember, are reference planes, and every family that we create is going to have a series of these reference planes. And we're going to start off with these reference planes by creating a skeleton of the object before we model anything. So it's good practice to go through and create these grid lines. You notice here that these grid lines can be named so that we have reference when we're actually creating the 3D objects as to which plane we're talking about. Also remember that these are not lines, they're planes, so they actually have 2 dimensions. They're not just single lines. If I was to look at the left plane from the right side, okay, the left plane is now actually entitled an infinite direction in every direction. So now I'm actually looking at the face of the left plane in the X direction this way and the Y direction up, forming a plane there. Just the same as if I'm looking down here at the top view. I have the X direction this way and the Y direction this way, which, let me correct myself here, in the front view would make this the Z direction and the X direction. So this, when we're in the front elevation, could be considered the Z. This could be considered the X. So the left plane is really would be actually the ZY plane. Okay, so the left and the center and the right would all be considered ZY planes if you think of it in a coordinate system like that. So the first thing that you really want to do when you create a family, like I said, is create this reference data. And from there, we can create this 3D geometry after we've went through and created all of the necessary planes. So every time that you have a shift, for example, from the front of this arm to the back of this chair, is a change of planes. The same as the side of this chair to the other side of the chair is a change of planes. So there are, for example, on this, if you consider this arm as a box, there are 1, 2, 3 on the inside, 4, and underneath is 5 planes. Same amount of sides. I'm sorry, there's 6 planes, 1 on the back as well. So you have 1, 2, 3, 4, 5, 6. So there should be essentially 6 grid planes just for this side arm here. So let's go ahead and start making a family here. I'm going to walk you through the steps that I like to follow that make it seems to make things go nice and easy. I'm going to go to File, New. Oops. I apologize. I'm going to go to File, New, and hold to make sure I go to Family there. Okay, so after I go to the new family, there's going to come up with a template window, similar to what AutoCAD would give you. If you remember, by default, you usually pick ACAD for AutoCAD. Here, you're basically selecting the host that you want. For example, if I was going to create a light fixture that was based off of the ceiling, I would select this template because it would allow any family that I created to snap to that ceiling. or have a reference to the ceiling. So if it was actually suspended from the ceiling, I could still create it. If I was going to do something that was roof-based, I could do this. If I was going to do a roof vent. Floor-based, if I was going to do a piece of furniture, you would want to probably do a floor-based since it sits on the floor. So you can see here there's different templates for whatever you might be creating. Door template, if I was going to create a new door. And you can see in the preview there that it kind of gives you a wall to work with. And that will, and with that, you wouldn't really want to create a door without using a door template because you have that door to work with, which allows you to snap in on a wall, and that tells Revit to cut a hole or an opening in that wall. So you would want to use the door template if you were going to create new doors. Furniture template. Okay, so what we're going to use now is just a generic model floor-based. I'm going to recreate the refrigerator, but this time maybe with a little more detail. So I'm going to go to generic floor model here, hit open. Okay, so we're back in the family editor, the same one that we saw with the chair, but this one's obviously a new empty document here. We still haven't given it a name or anything like that. If I go to my front view here, we'll see that there's the reference level. This green box here represents the floor slab. Okay, the material of this doesn't reference anything to your project. This floor is just here for your reference while you create these families. So there's no significance to the thickness of this floor or anything like that. You're really concerned about this plane right here, the reference level that we're going to construct on. This is by default the center of that reference. So, and we're going to add different reference planes as we saw before here. Okay, so after you do that, it's always good to get a reference image. So I'm going to go to the site again that we used in class to get the specs for my refrigerator. I like to use Wolf and Sub-Zero, especially for the demonstrations, because they have, if you remember, amazing CAD files, so I can get the measurements that I need for this guy. Okay, so this is Sub-Zero and Wolf's site here. I'm going to go to Built-in Refrigerator. And find one that maybe this time has a ice maker. This is a pretty big refrigerator, pretty straightforward and simple. Let's see what this one has. Okay, so looking here, I have my overall dimensions for the refrigerator, and we had said we'll want to take that a step further. That would be okay if we were just making a box, but we need to know other dimensions other than this. So what I'm going to do is go to specifications and downloads, and you'll see under the CAD downloads here, there's 2D and 3D drawings. I'm only interested in the 2D drawings, so I'm just going to download the classic stainless 2D, save that. And save this a place where you can find it. Extract the files in the same folder there. So now that I've extracted that, I have my 3 different views. You can see Sub-Zero is nice enough to provide these free of charge. I have a front elevation, a plan view, and a side elevation. Now most companies are going to produce something like this, so you'll just have to look for it. It might not be as easily available as Sub-Zero and Wolf. I know places like for plumbing fixtures like Kohler offers their CAD blocks for just about all of their products, and even some Revit files or families already made. So if there's a Revit family that you're interested in, you might check out Kohler or some of these sites. They actually make these Revit files for you as well. So this time we're just going to learn how to make our own. So what I'm going to do is, most of the detail I'm interested in right now is going to be on the front. So I'm going to open that up. Alright, so there's the refrigerator in AutoCAD. So we can see that we have a detailed drawing. It even shows hinges of the refrigerator we're looking for. Now we don't need precise, obviously, for this, because we're not using this Revit drawing of the refrigerator to actually create the refrigerator, but we do want it to show the detail. If we decide to do 3D renderings, it's good to have this already done to some extent of the detail. So I'm going to basically do the vent cover, both doors, 2 handles. I'm going to do the ice maker, and it looks like the toe kick is open on this one. I'm not going to worry about the hinges or anything like that, because the detail level that we're concerned with, like I said, the idea of this Revit rendering would be the space. It's not necessarily going to be the refrigerator. So things like these hinges are really not that important. Okay, we can skip that. Even the things like you can see here, there's a little trim that goes around the door. See that trim? That's really not important. I'm focusing really on the overall detail. Something like this would be might be okay to include later, but we're not really worried about that either, and we're not worried about the hinges inside the opening here. We just want the overall picture. With that said, what I do next is just come in and pull some quick dimensions off of here. Now I'm not going to have dimension styles or anything set up, because this is, remember, the Sub-Zero file, but I can come in here and just get rough dimensions from opening to opening. Okay, so we can see that that's 9.75 inches. Measure the door here. Okay, I'm actually getting some good snaps here because I'm getting even numbers. Sometimes you'll get crazy numbers, and it's okay to round up to maybe the next hundredth, like this, with 2 decimal places. So the doors are 69.75. Again, I'm not interested in all this other stuff here, so I'm just going to go straight from the bottom of the door to the ground, and we'll skip all of this stuff. So I'll go down to the bottom of the feet there. And that's 3.58, so I'm going to go ahead and round that up to 3.625, which is going to be 3 5/8. It's a bit of a big jump, but we can fluctuate that there. That's okay. So those are 3 dimensions that I can get started with. So what I'm going to do is go back to Revit. So I'm going to actually window this for now to this side over here. One good thing about the Windows software will allow us to do this. And you drag it to the left and the right until you see the little gray box appear. That'll allow you to jump back and forth between these two while you get this thing started. So what I'm going to do is create my reference planes now that we noticed in that. If you remember from the chair, there were a series of skeletons. There was a skeleton of reference planes, and I always construct every face first. And we'll see when we get to the 3D modeling part that why that is important to do that. Okay, so I'm going to go to my front elevation because I'm looking at the front view, so I want to make sure I'm in my front elevation. You'll see the reference level here. I'm going to go to the Home tab, and I'm going to go under Datum, and you'll see here that there's a reference plane and there's a reference line. Now remember, we're working with planes here, so all of these skeleton lines should be reference planes, not lines. And I'm just going to roughly sketch the 3 horizontal lines that I just measured. Make sure that they're straight across. We're not really worried about dimensions just yet because we can change those, right? We can add. We'll see. We can change that. I just need to get them out here for now. If I double check myself, I have one plane. Okay, I have 3 different dimensions, but I also have openings here. So I should have the top of my refrigerator here. Okay, that represents this. I should go 9.75 to the bottom of the vent, and then I have a gap. So really what I need here is another line across here for my opening. Whoops. Okay. There's no gap there. I go straight from this dimension to the next. So a good rule of thumb is if you're using AutoCAD, whenever you have a break in dimensions like this, you're going to have a gap in planes there. I want to be consistent. And while I'm in the front, I know that I'm going to have two sides, so I'm going to go ahead and draw those two sides. Notice that I'm not worried about dimensions just yet. I am worried that they are nice and straight. I'm going to have an opening in my door here. Now notice that this door is not in the center, and by default I had that center snap there. I can still use this if I want to, but I'll have to rename it. Usually I'll just leave that center there. Hopefully not to cause any confusion. I'm going to go ahead and make this one skinny. I'm going to draw two vertical lines here. Okay, that represents that opening there. It's a little thicker than what it's supposed to be. And then I have my right side here. Now I'm going to need more, I'm going to need additional grid lines for the handles. And I'm also going to need grid lines for the ice maker, or the water dispenser. But I'm going to go ahead and get these set now so it's not quite as a mess. So what I do next, is come in here, and I see that's 9.75. I guess the first thing to do though would get the overall height here, and we can go back for the overall height to the overview here, and you'll see that it's 84 inches. So that tells me that this top one, what I did, remember, is drag that. You can drag the extension line down to whichever plane you want to reference by clicking and holding on the circle. And then hit the dimension here, and this is supposed to be 84 inches. Alright, and remember to pin that, just like walls. After you create these reference lines, it's good practice to go ahead and pin that in there. So I'm going to use the pen tool under the modify tab there and find my pen, and that'll lock that in place. Okay, so there's my first dimension. Now this is my center, so we'll consider this to be the center of the refrigerator. And if I go back to the overall dimensions again, I'll see that the width is 42 inches. Okay, so I select the right side of my fixture. 42 divided by 2, 21 inches. And I'll pin that. And this left side here, this is my center, this is going to be my left side, and this is going to be 21 inches. And I'll pin that. Okay, now that I've created these, it's a good idea to be consistent and name these as you go. You should actually do it as you go along so you don't confuse yourself. I kind of skipped that step. So I'm going to go back to my top plane that I locked in there at 7 feet. Right click and go to properties. I'm going to give this a name as top REF refrigerator. Okay, and then you'll see now that that plane name appears on the screen. These other names, they're nameless, so you really don't want to have that, because what you're gonna have 20 to 25 different planes. You're gonna want to know what planes that you have. So by naming them, it'll save you the confusion. So name all of the ones that you create. So this is going to be the right side. This will be the left side. Okay, this is by default. Remember, this guy was named center, left and right. I'm going to rename this. Maybe it won't let me, since that was the center. We used to be able to rename this. Yeah, you can still rename it. For some reason it was being difficult. So I'm going to name this center of refrigerator, because it could be center of it. There's center of a lot of things on this refrigerator that we could have, and to eliminate any confusion, it's good to be very descriptive, right? Because I could have the left side of right door, or I could have the left side of the entire refrigerator. So I'm being very descriptive when I name these planes. It's good to get in that habit. Also, another thing, just for ease of visibility, would be I'm going to unlock this and drag this down a little bit, and then repin it. And I'll go in a hierarchy so that I don't accidentally find myself clicking on the wrong plane. I'll do the outside planes, I'll make them a little bit shorter than the other planes. So here's the center, so it should be probably the tallest. These guys represent the same thing, so they'll be a little bit lower, but not quite as low as the outside. You know, this doesn't really matter for anything other than being able to quickly reference which plane you're looking for. So this is going to be this left side of the right door. So I'll say left side, right door. Okay, this is going to be the right side of the left door. Right side, left door. And I'll have to come to my drawing to get those dimensions because those dimensions aren't available in the overhaul. So I'll come here and I'll measure roughly there. And I'll see that that's 16.87. 16.687. So let's see. I'll go ahead and make that 16, and we'll stick to 625. So we'll round that down to 0.625. So that's going to just give us 16 and 5/8 there. So I'll select this and do 16 point. Let's see. I'll just do 16 point. Well, I'll just do 16.69. That's no big deal if you want to have rough numbers in there. Whoops. You need to make sure you put inches in there though. For some reason, something funny going on here. It's a little harder to work with this small screen. Let's see. Left side of refrigerator. That's good. Left side right door. That's not right. There should be right side left door. Right side of the left door should be over here. So I'm actually going to drag this over. I'm going to change this to 16.69 inches. That'll bring it back over there. So that right side left door. Left side right. This should be, yeah, right side left door, left side right door. And because I'm more concerned about the dimension of the door, and I'll let the gap have whatever's left over from my rounding, I'll measure the side of this door over here. And that's just going to be 25 inches. So okay, this is going to be 25 inches. I want to measure this with something that looks a little fat here, so I want to use my measure tool up here under the modify, and that's showing 4'8". That should only be at 42 inches. So I'm going to go back to where I locked in my sides here and check to see if this got moved somehow. So this is referencing the center of the refrigerator. This is the side of my refrigerator. That's 21 inches. That's right. So this needs to be 21 inches. The left side of the refrigerator should be 21 inches from the center as well. And if not, you can see it's 2'11". So I accidentally made this side bigger. So there's the center of the refrigerator. I need to change this to 21 inches. And then lock that. And I need to repin this guy back in place since I unpinned it. Now I need to make this door thicker again. And remember, this door is 16.69 inches. Alright, there we go. That looks better. I'm going to make the screen larger here. Okay, so there's our opening in between our doors. There's the top of the refrigerator. Here's the left side of the refrigerator. You can start to see it coming together here. Left side of the refrigerator. Right side of the refrigerator. This is the center of the refrigerator. This is going to be the top of the toe kick here. This is going to be the vent, and this is going to be the space in between the vents. So go ahead and do those now. Start from the bottom and work myself up. See that that's 3.58 inches. So I'm going to give this a name. You can do top of coat. You're going to use the doors more, so instead of doing top of toe kick, it's probably better to do bottom of doors. But again, whatever works best for what you're doing is fine. I'm just concerned that you make sure that you name it. Whoops. Make sure you put in the inches. I'm still not jumping back and forth in computer programs here. There we go, 3.58 inches for my toe kick. Pin that. And doors are going to be, let's see here, we said the doors were 69.75 inches. Pin that and name this top of doors. Alright, and this is going to be the bottom of the vent. And the height of that is going to be 9.75 from the top. And I'll pin that. Alright, and there's the gap between the top of the doors and the vent. Bottom of vent, top of refrigerator, and top of doors. So the front looks pretty good so far, minus the handlebars, or not the handlebars, the door handles. The center plane, try not to let that confuse you with what's going on here. It's not, like I said, not necessary that you actually have it. I keep it in there because I reference the width of my overall refrigerator from it and cut it in half. Remember the 1'9" here and the 1'9" here. Okay, so now we need to go to the side plane and create the side reference planes. These are only occur on the front plane, so I need to go to either the right or left side. I'll go to the right side, and I'll throw in some more planes. So I need the front of my doors. I need the front of the refrigerator and the back of the refrigerator. I can open up the other drawing as well as the side elevation here to see if that's the only three planes that I need. Oops, I hit cancel. Try that again. Okay, so I can see here the front of the refrigerator here stops. There's a bit of a gap there. There's the vent and the door. So the vent and the door are on the same plane here. So I only need one plane there. So I need one for the front of the refrigerator, one for the front of the doors. I'll need a couple here for when I do the handles. But to get us started there, and I need, let's see. Looks like the toe kick is set back some, so I'm going to need another one here for the toe kick. This is actually really thick here. This is a lot deeper than normal. Let's see what this stuff is here. 4.7 inches. Okay, that's 1.7 inches. So what I'm going to do here to make my life easier, so I'm not really concerned about all this detail here, again, because this is just a Revit file, I just need the refrigerator to look like it's supposed to look like from the outside. So if a client were to see it and they had chosen this refrigerator, that it would make sense. So there's 24 plus the doors, 1.7. So we'll say that that's 24.25 deep, and then with the doors it's 1.7. I'm not even going to put that little gap in there. I don't find it as being necessary for this. So I'll do 24 and 1.7. Notice I'm including that gap in there though, because I do want to make sure the refrigerator is the correct depth, especially when it comes to space planning. If it comes to a really small tolerance, I want to make sure that my depth is at least covered in full. So I need to make sure my width, my height, and my depth are exactly what they should be. And I can double check this with the schematic here, and you can see the depth with the doors. It's 24 to the depth of the top. This is actually looks like it's showing an open door, the width of the door there. So it's showing 24. And I'm going to add that on there. It's a safety buffer almost, so I'll have a few different planes here. Should have 1 and 2. We'll see what that looks like. So what I'll do is I'll just make that an even 24. So I'll come out 12 from center, pin it, and this is going to be front of core. This will be 12 inches back. This is going to be back of refrigerator. And need to pin that. Yeah, this is center. Now this isn't the center of the entire refrigerator, this is the center of the core, so I'm going to rename that to be more specific. And this was 1.7. And this is front of doors. And I'll lock that by pinning it in there. And remember the toe kick was actually set back a little bit further there, so I'm going to do one more plane here. Reference plane, and I'll add this guy in here. .7. And I'll name this toe. Okay, so there's the rough skeleton of the right side view. I'm going to go ahead and stagger these so that I have a better understanding of which ones go where. Okay, so there's the right side view and the front view, and with that we can create the rest of the geometry. So go ahead and gather all your lines, make sure they're all named, make sure they're all locked, double check yourself, and we'll come back here and we'll start with creating the actual geometry. Alright, so let's go ahead and start adding the geometry necessary to create this refrigerator. And you're going to find out that it's going to be a breeze now that we've actually went ahead and created all these grid lines. It's going to be very simple to create the base of the rest of this refrigerator. So I'm going to go to the front view. And looking at this guy, I can really see the outline of everything, so I just need to start putting it in there, basically. What I'm going to do is go to the Home tab, and I think I'm going to create the doors. Actually, I'll create the base of the whole thing first, so what I need to do is set my work plane. Okay, so by default, you can see the reference plane is set to the center of the core. I basically want to change that to be the back of the refrigerator. Okay, it needs to be a reference plane that corresponds to this view. Obviously, the right side of the refrigerator doesn't make sense here. You can't draw on this line. That would be very hard to do from this view. So the reference plane that you pick needs to correspond to the view you're actually looking at. So it needs to make sense with the view. The back of the refrigerator would be the far back of this refrigerator in this view, so that makes sense. So I can hit OK there. Okay, now that I've set my work plane, I need to go to extrusion. Okay, and under extrusion, you're going to have your draw tools here, which is normal in Revit, all of your draw tools. I could do individual lines, but since I'm dealing with rectangles here, I'll just draw a rectangle for the whole refrigerator there. And I'll lock this to my grids. And you'll see why this would be important when we would start talking about parametric data next week. But it's good to go ahead and get in the groove of locking these reference lines to your reference planes. Or, I'm sorry, your model lines to your reference plane. So lock these in once you've drawn them. And after I do that, actually before I do that, I want you to notice that there's a depth setting here. So I could insert the depth here if I wanted to, or in an offset. However, we took the time to create all of the grid lines, so since we've actually done that, I'm going to leave that at 1, and I'm going to check here. And I'm going to go to my right side view. Okay, and we'll kind of get an idea what's going on here. Okay, so here's the back of the refrigerator. Now here's the geometry that I just created. And because we're working off of the planes, when I work off of the back plane, by default the direction positive is this way, right? The X direction or even the Y direction is positive in this direction. So entering a positive value is going to extrude in this direction. If I would have drawn on the front plane, I would be within my bounds. But since I drew on the back plane, it's going to be on the other side of this reference plane. So the direction of X would be this way, the direction of positive Y would be this way if we were in a coordinate system. Remember, Revit isn't in a coordinate system, but if we think in our minds of that being in the positive direction of X or the positive direction of Y, we can see why this is extruding this way with positive values. However, we took the time, like I said, to draw these grid lines, so I can just select this and drag this blue arrow to the point where I need it to be, which is here, and I'll lock it. Okay, if we didn't have that grid line, we wouldn't have the capability to just be dragging it places. I never recommend dragging things without grid lines, but since we have these planes, we can snap to these planes, like I said, by simply dragging, and that's a wonderful feature when it comes to modeling this thing. So if I go to my 3D view here, we'll see we have the start of our wonderful refrigerator, just this box for now. And I'm holding Shift while I hold in my middle mouse button to orbit here. So if you hold down Shift while you hold in your middle mouse button and move your mouse around, you can orbit. And by default, the 3D view is an isometric view here, and it's really boxy, you can see. Kind of like if you were to draw on your paper with a 30-60 triangle or a 45-45 triangle. The lines are going to be really parallel and straight. And we'll get better shots of this as in the next few steps. We'll correct that. So back to the front view. This time I'm going to draw on the correct plane. So what I'm going to do is go to Home. I'm going to set my work plane to be the front of doors. And I'll hit OK. And I'll do an extrusion again, and this time, just to show you that you can do this, I'm going to use individual lines instead. Now you can see by using individual lines to draw this vent that I'm not getting the option to lock as I go around. So if you want this to lock, you have to come back in with your Align tool, if you remember from previous lessons, and select the grid lines, and then select the lines and lock them individually. It's important that you lock these to the grid lines. They need to be locked. So make sure you take the time to do this. We'll need it for our future, like I said, next week when we start talking about parametric data, we'll want to make sure these are locked, so it's good to go ahead and do that now. Okay, now I'll hit my check mark there. Again, I could do the depth, but we know that the depth for this is a weird number. I think it's like 1.7 or something. So again, I'm going to leave this as 1 foot. I could, remember, change this if I wanted to in here. Don't think that you have to drag it, but since we have the nice reference planes, I can go to my right side view here. And here's the extrusion that I just created, the 1 foot extrusion. I need to drag this back to this plane and lock it. Okay, so there's the front of my vent. Go to my 3D view. There's the vent cover on the front. Back to the front for the doors. I'm actually on this one. I'm going to go ahead and jump to the right side. I've been drawing in the front view because it's convenient. If you've noticed, it's convenient just to draw these rectangles. You can draw in any view that you want to. You can draw on the top view. You can draw on the right side. To show you, I'm going to jump to the right side view. And this time I'm going to draw from this side. So I'm going to do an extrusion from the work plane. I'm going to save the project if you haven't done so. It's been a while, so I should probably save this. Let's see. And let's see, this is going to be, it's good to name this correctly. Since you're modeling it after a specific refrigerator, it's good to actually do like model name and all that stuff. So that way you can create your own library so you don't have to redo these in the future. So this is BI for built-in, -42 for 42 inches, SD, I'm guessing, has to do with the doors side by side. So I'm going to do BI-42 SD, BI_42_ SD. And it'll save it as an RFA file. So for my next plane, I'm going to select the outside, right side of you see, right side of refrigerator. And I'll do an extrusion, do a rectangle, snap this. Now remember, we want to stop before the toe kick because there's going to be a toe kick here. And then I'll lock these in. And again, I could hit the depth here, but I'll drag it later. Go to my front view. So here's the new extrusion coming off the side. I'll drag it over to the left side of the door here. If you look at the lower left-hand corner of my screen right now, you'll see that it's snapping to the right side of the left door. That's not correct, so I need to zoom in after I snap it to that one and move it over before I lock it to this guy. Alright, so there's that right side door. If I go to a 3D view now, you'll see that door is properly placed there. So for the next one, I'm going to keep it simple. I'm going to just keep drawing from the front plane. Show, home, extrusion. Whoops. Before I do this, remember it's necessary to always set your work plane so you know where you're drawing. You can change it later. It's best just to go ahead and get it right. So I'm going to do front of core. And I don't really like this space down here. I'm actually going to make that a little bit bigger here after I get all this done. And you'll see how easy that is. Since we've been locking this to the planes, all we have to do is change the dimension of the plane, and it'll take care of it for us. Okay, so I've got all my locks there, so that's good. Okay, that, and go to a view where I can see the depth of this thing, and lock that. Alright, so if I go to my 3D view, I have the two doors there. I guess that gap's not too bad looking at it from this. I was concerned that the gap was going to be too small to actually see in a view. And it looks like it's showing up there, so that's okay. Now, I mentioned before how boxy this looks, and it looks really boxy. And I don't really like, when I'm modeling stuff, to see something boxy. I kind of like a perspective view. So in order to do that in Revit, you need to add a camera. So if you want a perspective view, you need cameras instead of 3D views. So if I go to View, Camera, and I click out here, drag, and the red dot represents my focal point, so right in the middle of the refrigerator, and I'll click. And that'll drop a camera in there, and I can make the adjustments with the blue dots by dragging them down. And I'll drag this other one on top here down. And I'll drag these over. Alright, and I can get rid of this frame by turning it off down here. So that's a better view, in my opinion. It's nice, like a 2-point perspective drawing. You can see that it's falling off to the 2 points on the right side and the left side. So this is a little better of a view than, say, this, where it's more of an isometric, and everything's the correct length on the depth. So in order to get that nice 3D view, you need to add a camera. Alright, so let's move on and go ahead and add the vent holes in the top. I'm going to go to my front elevation. Now, if you're not familiar with modeling, there's things that are called booleans, and they're popular in just about every program that you use. And Revit, they're called voids. And basically, the whole concept is you have two masses or two geometries, and you subtract one geometry from the other geometry. So to do that, you need one geometry to exist, which we have our geometry here, our base geometry, and then we need our actual cutting shapes. So I'm going to go to the home, and I'm going to set my work plane to the front of the doors. And instead of doing extrusion, I'm going to go to void forms here to the right. Okay, and I'm going to do a void extrusion. So you can see the same shapes that you have here are duplicated, but with void in front. And the void allows you to cut this shape out of another shape. So let's go ahead and do a simple void extrusion here. And I'm going to draw a series of rectangles here. And I'm going to go back to AutoCAD and see what we're dealing with here. Go to the site too to get a good idea. So it looks like there's 1, 2, 3, 4, 5, 6 holes, or vents. So that's 1, 2, 3, 4, 5, 6. So each one of these voids is approximately 0.82 inches. So I'll just drag a rectangle here for now, dimensionless pretty much. Alright, and let's see. It's going to be 0.82 inches. And it looks like it didn't close up there, so I'm going to select this segment and drag it down until it snaps, and then drag this over until it snaps. Those need to be closed in order to create geometry. Okay. I'm going to do a smart dimension here from the top. Get my first one going, and this one should be about 0.585. And if you notice, nudge my other number here, so I need to change this back to 0.82. Okay, and I'm going to select all these lines. Now you can't do an array with model lines like this, so you actually just have to copy them. It would be nice if that feature was available maybe in the future. You can only do an array of elements, so what I need to do is do this copy and then make sure I do multiple. And I want to go back here, 0.58, that's what we set for this. Oh, 0.58 inches. Looks like it's going to eyeball this here. My base point here is in the center, so it would have to be the thickness of this plus the thickness of what I want. So if my base point's here in the center, I would have to tackle on the extra additional. So one, two, three, four, five, six. Okay, so there's the 6 that I'm looking for. I'm going to do see if I can get away with a shortcut here. I'm not sure if this will work, but we'll give it a shot. I'm going to basically no, it's not going to allow me to snap to the middle there like I wanted. I'm just going to nudge these to where they look correct. So the spacing here and here, again, this isn't an exact science. It doesn't need to be. If we wanted to take the time, we could measure them out here, but it's really not necessary. So I'm going to hit Tab to select the chain, then click, and I'm just going to use my arrow key to nudge this down a little bit. And I'm going to just space these out so they look right. So again, Tab and then click. And you can select everything by dragging a box on it. And after you drag the box, you can nudge everything down with the arrows again. So that looks close enough for what we're going for here. That'll work. Okay, so after you get all of your shapes drawn and placed where you want them, go ahead and hit the check box. Okay, I'm going to go to my right side view. And you can see by default we still have that 1 foot depth, so I'm going to change this so that it's not quite so deep. And this value doesn't necessarily matter. I wouldn't make it really shallow like this. I might take it back some. It could go all the way through if you wanted it to. It's not an exact number, so don't worry about that too much. And then click. So there's our extrusion. If we go to our 3D view, we'll see that our vent extrusions are now in there. So it's coming along here on the front. So basically the next step, I'm going to go ahead and add the ice maker. And we're going to, it looks like for the toe kick, because there's a weird toe kick, we're going to do another extrusion down here as well. Let's go ahead and do that now before we move on. So I'm going to go to my right side view. And let's see, I'm going to do a void form, void extrusion. Set my work plane to the right side of the refrigerator. And I'm going to select here. Just draw a box and block that in there. Alright, and I'll hit OK. I'll go to the front view so I can see the extrusion itself, and I'll drag this to the other side and lock that. Now if I go to my 3D view, you'll see that that notch is now deeper. So we achieved that by doing a difference. We could have also drawn that shape if we wanted to from the side profile. Either way works, whatever, whichever method you would rather do. Like what I mean is basically when we drew, when we created this core, instead of creating the shape from the front, we could have drawn this shape, the front face coming down, and then we could have drawn this little notch and over and extruded that whole shape back. Or we could do the process that we did now and clean it up with an extrusion after the fact. So either way, there's no correct way. This takes a little more computer power, maybe a little more geometry involved. Computer has to calculate that cut, but because we have two nice faces, we're not worried about complex cuts there, so it's not really a huge deal. So whichever way you prefer is fine by me. Just know that there's a couple different ways that you can do it. Okay, so we're gonna fade to black here for a second, and we'll come back and we'll add the ice maker, or the water maker, or not the water maker, but the water dispenser and the handles, and this refrigerator will be ready for Revit. All right, welcome to the home stretch of the refrigerator here. We're going to add those next two elements that I was talking about, and that would be the extent of the level of detail that you need to worry about in Revit as far as your refrigerator fixtures go, or families go. So I'm going to go and add in the other planes that we didn't have before. Remember, I left out planes before just to keep it simple. So I'm going to go to my front view. And the home tab, reference plane, and I'm just going to rough in these handles, make them nice and wide for now. Notice I'm not crowding this line over here either. I'm just making them out here in the middle so I don't accidentally snap or something and cause myself to have to back up. So I just rough those in there. Now this is going to be the right side of right handle. This is the left side of right handle. Just while I'm doing this, if you remember naming these, the reason they're important, remember when we were creating work planes, if we hadn't named these and they were just random plane names and numbers, you could see where that would be a problem. So it's good to name these correctly. Excuse me. Alright, so now I need to put the measurements in here. Go back to AutoCAD. You would have to be creative as far as coming up with these dimensions if AutoCAD wasn't available. If an AutoCAD file wasn't available. I'm going to drag this to the left a little bit because I know it's going to be bumped. So I'm going to drag it closer. .0625. Looks looks like I'm snapping to, you gotta be careful here, I'm snapping to some arbitrary point here. See, my dimension line is off, so I need to move that out to this line here. Which one is this? The center of the refrigerator. I'm going to drag this guy over to here. This needs to be 23.0625 inches. There we go. And that gives us 1.5 inches here, which makes sense. So I might have guessed this pretty close to what it needed to be. Anyway, I'm going to pin that one. If you can't get the specifications, you kind of just need to make it look right. You need to at least you really need to have the overalls for sure. You need to have the height, the depth, the width. If you don't have the other specs, like I'm doing in AutoCAD, that's okay as long as you make it look like it's supposed to look. The idea is not to give your client a false idea or give your renderings false ideas with false information. So you really need to make sure that this looks like what you're actually going to use. So if you're going to use this refrigerator, model it. If you're going to use a different refrigerator, model it. Don't take shortcuts when it comes to things like that, because somebody's going to notice down the line and you're just going to have to redo something that you didn't need to redo to begin with. So always pay attention to the details up front. Okay, so this is, how thick is this? Yeah, 2 AutoCADs open. How did that happen? Okay, it looks like it's thinner than 1.5 inches, so I'll measure the width of this. That's 1 inch, so I'm going to change this to 1 inch. Oh, I need to select this line first. There we go, and I'll pin that. And I'm going to drag this line, like I said, closer to the center because I don't want this line to overlap and cause confusion. Again, for some reason when I select this, it's going to this first line here. So that needs to be adjusted out to the edge. .6. And this is 1 inch. So I pin both of these, and that gives me my handle references for the front of the refrigerator. Now I'm going to jump to my right side view. Delete that reference if you have it. It's not necessary. And I'm going to do a reference plane here. Two inches. Now I might have messed up here in picking this example. Let's take a look at the handles. Yeah, so these handles are nice and straight, which makes it really easy. But chances are you might find a fridge that has curved handles instead of straight up and down handles, which is probably going to be more common. So let's see if we can find something like that here. What's this handle option thing? No, they're still straight and easy. I'm looking for something a little more difficult. So, and this isn't something that you would need to do. Obviously, if your refrigerator has straight handles, make straight handles. But I wanted to prove the point that for the sweep tool. So I'm going to just look for a different handle style just for that point. And everything's pretty modern. Okay, to save time, I'm just going to make them up. We would want to make these like the picture, but I'm going to, like I said, to save some time, make that part of it up. So go back to the front, and I'm going to do the ice maker. And it looks like there would be a hidden line behind there, so it looks, if you can see, the thickness on this side doesn't necessarily match the thickness on this side. It's close, but there's probably going to be a need for another, another plane there. It's 16.86. I'm going to make that a little bit bigger, like I said, so I'm going to make that 6.25. So it looks like it's actually pretty close to just lining up with whatever plane this is. Right side of right handle. So we'll just reuse that. I'm going to delete this one we've been creating, and I'll use the right side of right handle for my constraint on the ice maker as well. Two more to go. .72. Pin that. .86. Pin that. Okay, so the first thing that we need to create here is an extrusion or extrude. So go to home. I'm going to select the work plane to be front of doors. And I'm going to do a solid void extrusion here. Right side of the handle. that. And I'll hit OK. Got my 3D view here to take a look at it. It's going in the right way there. Cutting through. Now, the reality of it is this thing can't be that deep, right? Because whenever you open up the refrigerator, you don't have a big box here. We're going to only dig into a little bit of this to give us a little bit of wiggle room there, pretending that we have that much space on the inside of the door. So we have an extrusion here of about 3 and 2. If we change this to 16, it'll give us a nice round number. It's 1/16. So now we have 3 and 1/16 is what the overall depth of this is. Again, it's no exact number, it's just eyeballing it to see that we have a depth there. Alright, couple touch-ups here, looking at it in a 3D view. We should be able to go to the Home tab. Actually, I'm sorry, you need to go to your isometric 3D view there. Camera view won't work, you need to make sure it's the view 1, not the camera view. Modify, I'm going to do join. Save the project if you haven't. I'm going to join those two together. Well, that'll mess with our exterior line. So I'm going to leave that as it is for now. You can skip that step for now. There's a couple different things that we can do to get by this seam line, and one was join it like I had there, but if we join, then we're going to end up with joining the outside, and it's going to look like there's no doors. So the other way would be to design or create an insert almost that goes in and covers up that seam. So we'll use that approach since we're still learning. It'll be extra practice. So to create this insert, we are going to do 2 different things here. We are going to create an extrusion. Our work plane is going to be set to the front of the door. Alright, and I'm going to create an extrusion that is the same size as the opening, but it's also going to have a inset. So I'm going to offset, and I'm only going to offset 0.125 inches. I'm going to hit tab for the chain here. .125, and I hit tab for the chain, and that'll give me the chain. So basically I did offset and I got the 1/8 inch space there, and that gives me a little thickness there. And I'll hit a check mark for OK. I'll go to my right side view, and I only need this to go back to the back of this opening, and I'll lock that in place. I'll go to my 3D view, and you'll see that covered that up. Now we have this shape here, but if we look at the actual image here, and this is again a little more detailed than what's necessary. Can't really get a good shot of it, but there's the trim that goes around the front of it, so we can clean that up by adding that trim on the front. We can eyeball that without grid lines. That'll be fine. So I'm going to do a new extrusion. Okay, so I'm going to pick my work plane to be the front of the doors, and I'm going to do an extrusion. I'm going to do a rectangle, and if you look at the image, it's a little bit bigger on the top than it is anywhere else. Okay, so after the fact, I'm going to use my arrow key to nudge that up some, and I'm going to use my arrow key again to nudge this over some. I'm going to do a 1/2 inch on the sides here. Again, I'm making these numbers up pretty much. Notice I'm not even working off a grid here because this is a detail that I don't really have the measurements for. I'm sure if I went to the AutoCAD drawing I would, but at the same time this isn't going to really matter on as much on the actual family as the overall dimensions would. This is kind of just adding extra details to have a nice solid family. So I'm doing 0.5 inches here all the way around, and then this will be probably an inch. Okay, and the picture shows curves up here. So under my tools, you'll see there's a fillet tool here. If I set my radius here to something like 0.375. Whoa, that's not 0.7. That's I put it in feet there, I think. 0.375 inches. Let's try that. That's better. That's still a little small. I can undo that by hitting Control Z and entering 0.5 here. See if that looks better. Yeah, that's better. Around the two corners. And the depth of this thing I'm going to go ahead and enter here. I only want my depth to be something really small, 0.125 inches. And I'll hit OK there. Go to my right side view. You'll see that it went in the wrong direction. So you could drag it out, but since we don't have grid planes here, we're just going to put a negative in front of the depth, and that'll flip it in the other direction. Notice that flips that out. So now I can use my join, and I'm going to join this guy and that. And that'll join those two pieces that I just made together. Whoops, I forgot to create my opening in this, so no big deal. Select that, go to my front view. After I select it, I can go to Edit Extrusion, and I just need to create another shape, right? This base plate represents the outside, so for the inside I need it to be the size of the inner opening. So I want to make sure I cover the thickness of that inside insert. So I'll lock that there. There we go, that'll work. Nice. So now we got rid of that line on the inside there. We have our little gasket or flange there on the outside that makes it look a little more believable. Okay, so we could go ahead and do some things here on the inside. That's a little more detail. You know, you probably would want to include something. We're going to go ahead and move on to the handles for now. So I'm going to go ahead and save it, go ahead and catch up, experiment some, fade to black, and when we come back, we'll have our last segment. So save it. I'll see you back in a second. Okay, so for the handles, as I mentioned earlier, the handles that are spec'd for this refrigerator, the actual handles that go in this refrigerator, are straight, long aluminum rods or stainless steel rods. And as nice as that looks, it's a little bit too easy for this tutorial. I kind of wanted to show you some of the limitations that we can push things to when we model stuff. So the tool that I'm going to introduce to create these handles is not going to create the exact same handles that were on the actual refrigerator when we look at their website. So like I said, what we're going to do is create a sweep to generate the handles to be more of a curve. So what I'm going to do is go to my right side view, and if you've never modeled anything in 3D before, there's terms in the field such as sweep, loft, extrude, and so on and so forth. And we found that the extrude tool is very handy because for the most part, that's everything that we've done so far has been with that extrude tool, with the exception of the voids. So between the extrusion and the voids, we've created almost everything. Now a blend and revolve A blend is more like a loft in other programs. So whenever you hear the term loft, you can think blend in Revit. Revolve could be considered, like in 3D Studio Max is considered the lathe modifier. However, in most other software, it's still revolve. So revolve's pretty popular. Sweep is still sweep. If you're a big SketchUp person, it's called Follow Me. That's what SketchUp's version of the sweep is. But for the most part, in every program that I've used, it's sweep. And here you have a mix of a sweep and a blend, which would be a mix between a loft and a sweep. So this would be considered a loft with a direction. Okay, so we're going to look at the sweep now. So I'm going to select sweep. Once I do that, it's going to give me options here for profiles. So basically the idea behind a sweep is you have a path and you have a profile. And what you do is you draw the path and then you select a profile, and that profile is created, basically it extrudes that profile along the path. Okay, so it creates infinitely many shapes of your profile along the path to create a solid. So I guess the best way to show it would just to show the example. So I'm going to do a sketch. I'm going to sketch a path here. Now I have the outside edge of my handle here. I've already used the reference planes. Technically, since I'm not going to create the handles that were on there, I wouldn't need it, but it's still going to come in handy to stop my curve here. So I'm going to do an arc. I'm going to start my arc up here somewhere, and I'll finish it down here. And I'm going to take my radius out to that outside of my handlebar, or handle. Okay, so there's my path essentially. Right? I've said that I need to create a path. So if I go to my front view, we'll see that there's my path. However, technically this should be on a different work plane, right? So that was my fault. I forgot to set my work plane. So what happens when you do that? Do you have to redraw it? The answer would be no, you do not have to redraw that. So I'm going to select, set my work plane to the left side of right handle. Hit OK. Okay, that should have bumped it over. If I go to front view here, yeah, so that moved it over after the fact I set it. And either way, that'll take care of you. So I'm going to go to my top view now. So let's see, I've created my path, so I can check mark that. Notice that I'm in a submenu here. I didn't exit out of the sweep when I hit the check mark. I only exited out of the profile. So I'm sorry, the path. So I created my path. Now I need to create my profile. By default, there's profiles that I can load. Like let's say I had a trim and I wanted that, you could see where this might come in handy creating crown molding or something like that. If you had a path that you needed to follow all the way around a room and you wanted to sweep that crown or that base trim, you could load that profile, or you can edit a profile. If you're just going to do something like we're doing now, you can just draw a sketch. So I'm going to go to my top view here, reference level. Okay, this black line here represents the line that I just drew. The purple dot represents the center of where my sweep's going to be. So that dot represents the line that goes through my profile. If I go back to the front view here, you'll see this is the front view of the refrigerator. This looks like a straight line, but if I go to the right side view, it's actually an arc, right? So this dot and reference plane represents where I'm going to draw my profile. So when I draw my profile, this is where I need to envision it being. And that dot represents basically a spot on that path. So if I go back up to my reference level, I can see that dot is there. So that tells me that's the center of my path at that point in the front view that we just looked at. So I need to base my profile on that dot. All right, let me show you. So let's see. I need to edit profile, and for this example, I'm pretty much going to just do an ellipse. Like something like that. So notice I've kept that dot in the center of where I want my profile to be, and then I'll check, and that'll back me out of there. And if I check again, that will complete that sweep. So now if I go to my 3D view there, you'll see that it gives me that curved handle. At the same time, it also took that ellipse that I drew. It took the ellipse that I drew and swept it along that path. So you can see where the connection comes in between the sweep and the profile. So basically, you draw a profile. You draw the profile and you sweep it along your path. So technically, this path could go a little bit further, or I could do something about this here, which isn't necessarily correct. Just leaving it like that, we would want to do something to correct that in the future. All right, so since we already have one done, there's no point in killing ourselves. We can just take this and copy it. We'll mirror it. Well, yeah, we'll go ahead and we'll create a copy of this guy. All right, so I copied that over. Go to my 3D view there. It's a little off. It needs to be nudged over some more, so I'll go to front. And what happened was when I created my handles, remember I created these planes, but since I'm not following what I was using before, my planes are a little bit off. It looks like it's actually cutting it off here, which is a bug that I've dealt with in the past. Let's see if we can correct that. It has to do with the cut depth it's cutting through, and since the geometry is a little more complex, sometimes it gives you errors here. Let's go ahead and get it copied over for now. So I used a mirror tool. If you're familiar with AutoCAD, there's two different versions. You can draw an axis or pick an axis, and for now I just pick this axis. That moves that over. Alright, so there's our two handles. So again, I wanted to show you those two handles simply because the other handles were just simple extrusions, and I wanted to show you the sweep tool. Okay, so that's basically to an extent the level of detail that we need to go into for this family. We're not going to worry about types for this. For example, up here under family types, we can create different widths and heights and depths of this refrigerator if we want to. That way they're already done. And we'll find, since we went ahead and created all those grid lines earlier, that it's going to make that simple. But this is something we're going to do in the next video. For this video, I just wanted to get you familiar with the modeling aspect of the families. Next week we'll talk more about the data and the parametric data and the types. So I will go ahead and get this video ready and post it. Basically, you're going to need to create this exact same video, this exact same refrigerator, I guess, and then there's also going to be two more families. So look for the assignment sheet to be posted, and once the assignment sheet's posted, you can pick from the list whatever two extras that you want to create, and that will be the assignment. So I'll go ahead and get that ready. Next week we'll look at, like I said, more specific and more advanced modeling of families and components. So I will see you back here next week.